All right, everyone, get ready because today we are taking a deep dive into the world of AI and math.
Sounds interesting.
It is, trust me.
Yeah.
It is. And, specifically, how can we teach AI to think critically about its own reasoning when it's doing math?
Oh, wow. Okay.
Yeah.
So we're not just talking about AI getting the right answer here, right?
Exactly.
We're looking at whether AI can actually understand, grasp the process of solving a math problem, even if, maybe it makes a few missteps along the way.
Yeah, because just spitting out the correct number, that's not really enough, is it?
Right.
It's like back in school when, you have to show your work, remember?
Oh, yeah.
Yeah. And your teacher wanted to see your thought process, not just the final answer.
Exactly.
Right.
And that's precisely where this new research comes in.
Oh.
They've developed a tool
Okay.
called ProcessBench.
ProcessBench.
Yeah.
Okay.
To analyze how AI approaches complex math problems.
Okay.
Step by step. It's designed to catch errors in reasoning, even if the solution ultimately gets the right answer.
Oh, that's kind of cool.
Yeah.
So it's like having an AI detective just scrutinizing every move the AI makes when it's solving the problem.
You got it.
Wow. But I mean, why is it so important to focus on the process, not just the outcome? I mean, if the AI gets it right in the end, isn't that what matters?
That's a question a lot of people ask, and it might seem counterintuitive at first.
Yeah.
But focusing on the process is crucial for building trust in AI. I mean, think about it.
Okay.
If we're going to rely on AI to make decisions in, fields like medicine, finance, we need to be absolutely certain that it's not just getting lucky with the right answer.
Yeah, that makes sense.
We need to know that it's thinking logically and consistently.
We don't want an AI making life or death decisions based on a fluke. Right.
Right, exactly.
Okay, so how does this ProcessBench thing actually work? Did they just have a bunch of mathematicians huddled over AI solutions, highlighting every little mistake?
Well, expert mathematicians were definitely involved in the process.
Okay.
But they weren't just proofreading AI's homework. They were actually using a much more clever approach to create this benchmark.
Okay.
First, they compiled a collection of some really challenging math problems.
Okay.
I mean, we're talking sources like high school math competitions,
Oh.
even international Olympiads.
Oh, wow. Yeah, I'd be reaching for a calculator and a stiff drink for those.
Right, exactly. The kind of stuff that would make most people's heads spin.
Absolutely.
And so they had various AI models, some open source, some proprietary. You've heard of them.
Right.
Tackle these problems.
Okay.
You can kind of think of it as a team of AI students taking a really grueling math exam.
I'm already getting flashbacks to my high school calculus exams.
Right.
Yeah, not fun.
But, how did they actually determine if the AI was thinking correctly?
Yeah, because that seems like a pretty subjective thing to judge, doesn't it?
Right. And that is where the expert mathematicians came back in.
Okay.
They meticulously reviewed each step of the AI solutions.
Okay.
Identified any errors in logic.
Okay.
Pinpointed where the reasoning went astray.
Okay.
And this created a massive data set of 3,400 test cases.
Wow. Okay.
Each with, step-by-step solution and clear annotations of any errors.
So they created this training ground, basically.
Exactly.
For AI to learn how to spot errors.
That's a great way to put it.
In its own reasoning. So having a coach analyze game footage, kind of.
Yes. Great analogy.
Okay, so we have our AI students taking the test, our human coaches grading it, so to speak.
Right.
And now we have these you call them process reward models.
Yes, PRMs.
PRMs, okay.
They are specifically trained to assess the correctness of each step in a solution.
Okay.
So think of them as specialized referees, focused on those nitty-gritty details of the AI's thought process.
Gotcha. So the PRMs, those are our specialized referees.
All right.
What about the second type of AI model?
Okay.
What role did they play in this whole mathematical showdown?
Right. So the second type of AI model they used was called critic models.
Critic models?
Yeah, and these are general language models, some that you might have heard of, like ChatGPT, for instance.
Yeah, okay.
So these critic models are more like your color commentators,
Okay.
offering their expert opinions on the AI's performance.
Gotcha. Okay, so it's a bit of a David and Goliath situation here.
You could say that.
Yeah, with these specialized PRMs going up against, the more general critic models who came out on top in this mathematical battle.
Well, that's where things get really interesting and take kind of an unexpected turn.
Okay.
The results, they were a bit of a mixed bag, to be honest.
Okay.
And some of the findings were quite surprising. For instance, the PRMs, remember, the ones specifically designed to assess each step. They actually struggled with the more challenging problems.
Really?
And in fact, they even underperformed some of those general language models, the critic models that were just, kind of asked to give their opinion.
So you're telling me that the models that are like designed to be the math experts, they did worse than these generalists.
Yeah, no, it is surprising, isn't it?
Yeah.
It really is.
Why would that be?
Well, it suggests that simply training AI to identify correct or incorrect steps, that's not enough to make it truly understand mathematical reasoning.
Okay.
They need to develop this deeper understanding of the underlying concepts.
Okay.
The logical flow of a solution.
So it's not just about like knowing the rules of the game, but understanding the strategy behind the plays.
Yeah, that's a great way to put it.
Okay.
Yeah.
That's a really good analogy.
It's like the difference between, memorizing a formula and truly understanding the principles behind it.
Yeah.
You can plug in numbers and get the right answer sometimes, but if you don't really understand the why, you're going to hit a wall when you're faced with more complex or unconventional problems.
Absolutely. Yeah. This is fascinating.
Yeah.
It seems like there's more to mathematical intelligence, than we've realized, I think.
Yeah, for sure.
But if even the specialized models struggle, does that mean we're just doomed to have AI that just spits out these answers without actually grasping the concepts?
Well, not necessarily.
Okay.
This research actually gives us some really valuable insights into how to improve AI's mathematical reasoning.
Oh, okay.
And one of the most promising findings was the performance of an open source model called QWQ32B Preview.
And an open source model.
Yeah.
So not one of those big, proprietary models developed by the tech giants.
Exactly, that's right.
Okay.
And this QWQ model, it performed remarkably well. Even going toe-to-toe with, the much larger proprietary GPT-4o model.
Okay.
It was able to not only identify errors in the AI's reasoning, but also provide detailed explanations for its critiques.
So it's like having an AI tutor that can point out your mistakes and explain why they're wrong.
Exactly.
That's pretty amazing.
It is, yeah.
Especially for students, that might be struggling with these kinds of problems.
Right, absolutely.
Yeah, so do you have an example of how this QWQ model worked its magic?
Absolutely. So in one instance, the AI was solving a geometry problem.
Okay.
And it involved calculating the area of a triangle.
Okay, I remember those.
Right. And so the AI, it took a shortcut, used a formula that actually wasn't applicable in this specific situation, even though it did ultimately arrive at the correct answer.
Oh, wow.
But QWQ32B Preview, it flagged this error.
Okay.
Pointing out that the AI had incorrectly assumed the triangle was a right triangle, then provided the correct formula and explained why it was the appropriate one to use in this case.
Wow. So it's like having an AI math teacher right there with you, guiding you through the problem and explaining the concepts.
Exactly.
That's a game changer, I think.
It really is.
And the fact that this is coming from an open source model, that's really exciting.
It is.
Yeah, it suggests that with continued research and development, we can create AI that is not only powerful and versatile, but also transparent.
Right.
And accountable in its reasoning.
Yeah, and I think that's key.
Yeah.
That's what we need.
Yeah, this is all really promising, but you did mention earlier that even the best performing models still have room to grow. So what kind of limitations did they encounter?
So even QWQ32B Preview, impressive as it was, it was still significantly outperformed by a model called O1 Mini.
O1 Mini.
Yeah, and O1 Mini is specifically designed for complex reasoning tasks.
Okay.
And this highlights that general language models, while they are becoming increasingly adept at various tasks, they still have a way to go before they can fully match the reasoning capabilities of models specifically designed for these kinds of challenges.
So it sounds like we're still in the early stages of developing AI that can, truly think like a mathematician.
I would say so.
Yeah. So what does this all mean for the average person who may not be a math whiz, but, is increasingly interacting with AI in their daily lives?
That's a really crucial question. And, the implications of this research, they go far beyond just math problems.
Okay.
The ability to critically analyze one's own reasoning. It's essential in any field where AI is making decisions that impact people's lives.
So it's not just about making sure the AI gets the right answer, but that it's making sound judgments regardless of how complex the problem is.
Precisely.
Okay.
Yeah.
And this research is a big step toward that goal.
I think so.
Yeah, by developing tools like ProcessBench and continuing to refine AI's reasoning abilities.
Yeah.
We're moving toward a future where, AI can be a trusted partner in solving those complex problems rather than just a black box that spits out an answer without explanation.
That's right.
And that's kind of a scary thought, isn't it?
It is.
Just having this black box that we don't understand.
Right.
That's making decisions.
Right. Yeah.
So this idea of being able to understand and scrutinize AI's decision-making process, that's fascinating.
It is.
It almost feels like we're creating a whole new field of study, like the science of AI reasoning and oversight.
Absolutely.
That's pretty cool.
It is.
And this field is only going to become more crucial, as AI continues to evolve and integrate into, various aspects of our lives.
Right, yeah.
I think we're at a really pivotal moment in the development of this technology. And this research serves as a powerful reminder that we need to proceed thoughtfully and deliberately.
Absolutely.
Ensuring that we're building AI systems that we can truly trust and understand.
I agree. And that's what it's all about.
Yeah.
Right.
So we've got these AI models learning to spot errors, even in solutions that ultimately get the right answer.
Right.
We talked about why that's important.
Yeah.
We've seen that both specialized and general language models are making progress, but there's still work to be done, right?
Oh, absolutely.
This concept of scalable oversight, being able to effectively supervise these increasingly powerful AI systems, it's something that we hear a lot about.
We do, yeah.
How does this research tie into that bigger conversation?
It's really at the heart of it.
Okay.
As AI systems become more sophisticated and more capable, it becomes even more crucial that we have those robust mechanisms in place to make sure that they are aligned with our values and our goals.
Right.
And tools like ProcessBench, they provide a way to evaluate and improve AI's reasoning abilities.
Yeah.
Which is essential for establishing that oversight.
Okay.
Yeah.
So it's not just about having AI that can solve these complex problems.
Right.
It's about having AI that we can, that we can understand, that we can trust, and that we can hold accountable.
Absolutely.
It's AI that's not just a tool, but like a partner in navigating the complexities of the world around us.
Exactly. A partner, not just a tool.
Yeah. And that's a good way to think about it, I think.
I think so, yeah.
And this research is an important step in that direction.
I agree.
It's a reminder that building truly intelligent AI requires more than just teaching it to get the right answer.
Right.
It requires, teaching it to think critically, to understand its own reasoning process, and to be transparent in its decision making.
It all comes down to transparency and trust.
Yeah.
And I think that's something that's definitely worth striving for.
Absolutely.
Yeah.
All right. Well, that's a great place to kind of wrap up part one of our deep dive.
Well,
we've covered a lot of ground here,
We have.
and it's clear that there's a lot more to explore.
There is.
So in part two, we're going to dig even deeper into, some of the specific findings of this research.
Right. Sounds good.
We'll look at some more examples of how these AI models are learning to, spot errors and think critically about their reasoning.
Looking forward to it.
Yeah, me too. So stay tuned. Okay, so in part one, we were talking about, how AI models are learning to spot errors in math even when they get the right answer.
Right, exactly. And how that's important for building trust and accountability.
Exactly. And we were just starting to get into some of the specifics about these different models, like the PRMs and the critic models.
Those were the two main types of models they tested in this research.
Right. And you were saying how the PRMs, the ones specifically trained to evaluate each step, actually kind of struggled with the tougher problems.
Yeah, they did, which was pretty surprising considering they're supposed to be the math specialists.
Right. So what happened there? Why did they underperform?
Well, it seems like simply training AI to recognize a correct or incorrect step isn't enough to give it a true grasp of math reasoning.
Okay. So it's not just about memorizing the rules, but actually understanding the logic and the strategy behind the steps.
Precisely. It's like the difference between knowing how to play the piano and actually understanding music theory. You can hit the right keys and play a simple tune, But without that deeper understanding, you're going to hit a wall when things get more complex.
So you're saying AI needs to develop that same kind of deep understanding of mathematical concepts in order to really excel.
Exactly. And that's where things get really exciting, because one of the most promising findings of this research was the performance of an open source model.
Oh, interesting. So not one of those big proprietary models developed by, the big tech companies.
Right, exactly. This one's called QWQ32B Preview, and it actually performed remarkably well.
Okay.
It went head-to-head with much larger proprietary models like GPT-4o, and it was able to not only identify errors in the AI's reasoning, but also provide really detailed explanations for its critiques.
So it's like having an AI math tutor that can tell you what you did wrong and then actually explain why it's wrong.
Exactly. It's like having that teacher or professor right there with you, guiding you through the problem and explaining the concepts.
That's incredible, especially for, students or anyone who's trying to learn these difficult concepts.
It really is a game changer.
Do you have an example of how this QWQ model, worked its magic?
Sure. So in one test case, the AI was trying to solve a geometry problem involving calculating the area of a triangle.
Okay, I remember those. Lots of formulas.
Right, lots of formulas. And the AI took a shortcut and used a formula that wasn't actually applicable in that particular case, even though it ended up getting the right answer in the end.
Oh, wow. Sneaky.
Yeah, but QWQ32B Preview, it flagged that error right away, pointing out that the AI had incorrectly assumed the triangle was a right triangle.
Ah.
And then it provided the correct formula and explained why that was the right one to use in that situation.
That's pretty amazing. It's like it really understands the nuances of these mathematical concepts.
Yeah, it does highlight the potential for AI to not only solve problems, but also teach and explain those concepts to humans.
And the fact that this is coming from an open source model, that's really exciting because it means that, these advancements are more accessible.
Exactly. It democratizes access to these powerful technologies.
Right.
And that's really important for the future of AI development.
Yeah, absolutely. So this is all very promising. But you did mention earlier that even the best performing models still have room to grow. So what kind of limitations did they encounter in this research?
Well, even QWQ32B Preview, as impressive as it was still significantly outperformed by a model called O1 Mini, which is specifically designed for those complex reasoning tasks.
So O1 Mini is kind of like the top of the class right now when it comes to AI reasoning.
You could say that, yeah.
And what does that tell us about the state of AI development in this area?
I think it highlights that while general language models are becoming increasingly good at all sorts of tasks, they still have some ways to go before they can fully match the reasoning capabilities of those models that are specifically designed for those kinds of challenges.
Okay, so it sounds like we're still in those early stages of developing AI that can really think like a human mathematician.
I would agree with that, yeah.
So what does all this mean for the average person who might not be a math whiz, but is increasingly interacting with AI in their daily lives?
It's a really important question, and I think the implications of this research go far beyond just math problems, because the ability to critically analyze one's own reasoning, that's essential in any field where AI is making decisions that impact people's lives.
So it's not just about getting the right answer, but it's about making sure the AI is making, sound judgments.
Exactly, and I think this research is a big step toward that goal.
Okay.
By developing tools like ProcessBench and, refining AI's reasoning abilities, we're moving toward a future where AI can be that trusted partner in solving complex problems.
Instead of just that black box that spits out an answer and we have no idea how it got there.
Exactly. That's what we want to avoid.
Yeah, that's a little unsettling.
It is.
So this idea of being able to understand and scrutinize AI's decision-making process, that's really fascinating.
It is.
It almost feels like we're creating this whole new field of study the science of AI reasoning and oversight.
Yeah, it's like a whole new frontier, and it's only going to become more important as AI continues to evolve.
Right, because we're at this pivotal point in the development of this technology.
Absolutely.
And we need to make sure we're building these AI systems that we can really understand and trust.
I think that's the key takeaway from this research, and it's a reminder that building truly intelligent AI requires more than just teaching it to get the right answer. It requires teaching it to think critically, to understand its own reasoning process, and to be transparent in its decision-making.
And that transparency is really key for building trust.
Absolutely. It all comes down to trust.
Yeah, okay. So we've got these AI models. learning to spot errors even in solutions that ultimately get the right answer. We've talked about why that's important. We've seen that both specialized and general language models are making progress, but there's still a lot of work to be done.
Yeah, we're just getting started.
This concept of scalable oversight, being able to effectively supervise these increasingly powerful AI systems, that's something that's been discussed a lot lately. So how does this research tie into that bigger conversation?
I think it's at the very heart of it, because as AI systems become more sophisticated and capable, it becomes even more crucial that we have these robust mechanisms in place to ensure that they're aligned with our values and goals, and tools like ProcessBench provide a way to evaluate and improve AI's reasoning abilities, which is essential for establishing that oversight.
So it's not just about having AI that can solve these complex problems, but having AI that we can understand.
Right.
And that we can trust and hold accountable.
Absolutely. It has to be a partnership.
It's AI that's not just a tool, but like a partner in navigating all the complexities of the world around us.
Exactly. And that's what this research is pushing us toward.
It's a really fascinating journey, and it's clear that we're just at the beginning.
We are. The possibilities are endless.
All right. Well, this has been a really insightful conversation so far, but we're going to take a quick break, and then in part 3, we'll delve into some even more mind-blowing implications of this research.
Okay. Sounds good.
It really makes you think about like what the future holds for AI and math,
It does. It does.
Are we like on the verge of having AI mathematicians that can not only solve complex equations, but, maybe even push the boundaries of our mathematical understanding?
I think there's definitely a possibility, and it's a pretty exciting one.
Yeah.
Imagine AI collaborating with human mathematicians to explore, new theorems, discover innovative solutions, and maybe even challenge our current understanding of mathematical principles.
Yeah, that would be incredible.
It would.
But it also raises some interesting questions.
It does.
Like if AI starts contributing to mathematical advancements, how do we even ensure that we understand the reasoning behind its discoveries? Can we really trust mathematical proofs that are generated by AI if we can't fully grasp the logic behind them?
Those are questions that mathematicians and computer scientists are actively grappling with right now.
Yeah.
It's really like venturing into uncharted territory.
Yeah, right.
I mean, we're developing tools like ProcessBench to help us kind of peer into that AI thought process.
Yeah.
But we also need to develop these new frameworks for evaluating and validating AI-generated mathematical proofs.
So it's almost like we need to develop like a whole new branch of mathematics, the mathematics of AI reasoning.
Exactly. We need to bridge that gap between human intuition and AI's computational power.
Yeah.
Creating the system where both can contribute to the advancement of mathematical knowledge.
So in a way, this research isn't just about teaching AI to think like a mathematician, but it's also about challenging us to think differently about math itself.
I think you're absolutely right. It's a two-way street.
Right.
AI is pushing us to re-examine our own assumptions and methods while we're striving to guide its development in a way that aligns with our values and goals.
That's a good point. So for our listeners who are, really interested in this topic and want to explore it further, what are some key takeaways that they should keep in mind as they navigate this evolving landscape of AI and math?
I think the most important takeaway is that AI is not just a tool for solving problems. It's really a mirror reflecting our own understanding of those problems. And as AI becomes more adept at mathematical reasoning, it will challenge us to be more rigorous, more transparent, and more critical in our own approaches to mathematics.
And as we continue to refine AI's reasoning abilities, we'll not only create more powerful tools for solving these complex problems, but we'll also gain a deeper understanding of the nature of intelligence itself.
That's the beauty of it.
Yeah.
It's a journey of discovery, and we're all on this journey together.
Yeah, that's a great way to put it.
Keep asking those questions, keep exploring, and be prepared to be amazed by what we discover.
Yeah, I think we've definitely given our listeners plenty to ponder today.
I think so.
This has been a really fascinating deep dive into the world of AI and mathematical reasoning, and it's clear that we're really just scratching the surface of what's possible.
We are. The future is wide open.
Yeah, absolutely. So until next time, keep exploring.
Keep learning.
Keep learning and keep pushing the boundaries of what's possible.
Couldn't have said it better myself.
All right, thanks for joining us, everyone.